Hello, I am Mrs. Arnold, and today we are learning about oceans. Main idea is that the global ocean consists of one vast body of water that covers more than 2/3 of Earth's surface. Questions we should be able to answer at the end. What methods are used by scientists to study Earth's oceans? How did the oceans form, and how is water distributed on Earth's surface? So oceanography, as you learned in chapter 1, is the study of, it's the scientific study of Earth's oceans. If you go to chapter 15 of your textbook, in section 1 of chapter 15, you will find this timeline of developments in oceanography. The things that I find particularly intriguing from this is 1925, right here. A German meteor expedition surveys the South Atlantic floor with sonar equipment and discovers the Mid-Atlantic Ridge. Remember, before we started studying the ocean, we just thought that it was completely flat land. We have since discovered that our tallest mountain ranges in the deepest part of the planet is in the ocean. And also, 1977, we discovered that life exists at very, very extreme locations, including near hydrothermal vents. There is a deep sea ecosystem that includes giant worms and clams that can survive without energy from the sun. There are several technologies that we use to explore the oceans. The first we're going to talk about is sound navigation and ranging, also known as sonar. Floats, satellites, submersibles, and computers are also used to gather and analyze data. Sonar is helpful because it is used to learn about the topography of the ocean floor. One type of sonar is side scan sonar. This is going to direct sound waves to sea floor at an angle so that the sides of an underground hill can be mapped. The way that sonar works is that it sends a sonar signal. So the sonar signal is a sound wave. It sends a sonar signal to the ocean floor, and it times how long it takes for the sound to reach the bottom and then return to the surface as an echo. So scientists can determine how deep down the ocean floor is in that particular location because we know that sound travels through water at 1,500 meters per second. So they take how long it takes for that sound to come back to them and they multiply that by 2. They can determine the depth. And also, as you can see, because of that, we can figure out where there are hills and trenches in the ocean. A float is another device that is useful. It's useful because a float is going to collect information about water temperature, salinity, that is how salty the ocean is at that particular place, gas and nutrient concentration, wave motion, and speed of current. So it can give us quite a lot of information. This is a picture. This first picture is a picture of a float. And this picture kind of shows what a float does when it's out. Okay, submersibles are underwater vessels scientists use to explore the seafloor. An example of a submersible is Alvin. Alvin is the only deep ocean research vessel in the USA. The only one we have. And it's been in service for a very long time, since 1964. It was upgraded in 2013 for $41 million. And to operate Alvin, it costs $45,000 per day. So Alvin's pretty expensive, but he's also made some really big discoveries, like the hydrothermal vents. Satellites are another technology. They are used to monitor the surface temperature of the ocean, currents, and wave conditions. And computers are going to be used to help with collection and analysis of data. So where did our oceans come from? We have geologic clues that indicate that water has existed almost since the beginning of Earth. So to break this down, remember, the beginning of Earth means our planet is 4.6 billion years old. And we know that because of radiometric dating. And what geologic clues are we talking about? These geologic clues are going to be rocks that are nearly as old as the age of Earth. And they have been found So rocks that are nearly as old as the age of Earth have been found, and these rocks were formed from sediments deposited by water. So since we have really old rocks that were deposited by water, we know that water has existed almost since the beginning of our planet. Question is, where did water come from? There are two hypotheses. The first one is that water came from a remote source like comets or meteorites. In that these could have contributed to the accumulation of water on Earth. Remember, early Earth was very fiery and always being, hit with comets and meteorites. And if our early Earth contain the same percentage of water as meteorites, which is about 0.5%. That would have been enough to form early oceans. Okay, a local source for water is volcanism. So remember, early Earth was kind of hellish, which is why it's called the Hadean Eon. But this hypothesis says that water for early Earth's oceans might have come from volcano eruptions. Because when volcanoes erupt, they release gases like water vapor. So that is another way that the water could have come. And there's a pretty cool graphic in your textbook showing how volcanism could have attributed to the water on the planet. So how is water distributed? We know this already. Oceans contain 97% of the water that we have on our planet. And then 3% is going to be freshwater in ice caps, Greenland, in Antarctica, and also rivers, lakes, and underground sources. Our planet is known as the blue planet. 71% of planet, approximately 71% of planet is water, covered in water. But if you look at the hemispheres, you can see a variation in that. For example, the northern hemisphere is covered by slightly more water than land. So it's 61% ocean. But if we look at the southern hemisphere, there's far more water than land, with 81% of ocean. The global sea level, which is the level of the ocean's surfaces, has risen and fallen by hundreds of meters in response to melting of ice during warm periods and expanding glaciers during ice ages. Sea level change is also affected by tectonic activities. Also affected by tectonic forces. That causes parts of the Earth crust to lift or lower. So the sea level has risen at a rate of about 3 meters per year. Not meters, that would be really drastic. 3 millimeters per year between 19 1994 to 2010, which you can see looking at this chart. Our y-axis has the change in the average sea level in millimeters, and along our x-axis we have the year, and you can see that it has definitely made a change. Scientists hypothesize that this change is due to water release by the melting of glaciers and also the thermal expansion of the ocean due to warming. Okay, so all of the oceans are one vast interconnected body of water. They have been divided into specific oceans and seas largely because of historic and geographic considerations, which is how we get our Indian, Pacific, and Atlantic oceans. But do remember that all of them are connected, and they're basically all, they are, not even basically, they are all one ocean. The three major oceans are the Pacific, Atlantic, and Indian. We also have the Arctic Ocean in the Southern Ocean. You can see here how large each ocean is. The Pacific is the largest one at 155,557,000 square kilometers, but the Atlantic Ocean is growing bigger every year due to tectonic activities, which we will talk about when we talk about seafloor spreading. We're talking about plate tectonics. Okay, the polar oceans are the Arctic and the Southern Oceans. These are covered by vast expanses of sea ice, particularly during the winter. We see this picture of pancake ice. This will eventually thicken and freeze into pack ice. The ocean and atmosphere interact with one another. Oceans are going to provide heat and moisture to the atmosphere, and this is going to influence large-scale circulation patterns. So part of the reasons why we see hurricanes, or why we see different storms or weather patterns like El Nino or La Nina, is because of what the ocean is doing and how that then affects the atmosphere above the ocean. So this warm ocean water, for instance, in equatorial regions heats the air above it. This warmer air holds more water vapor formed at the Earth's ocean's surface, and that can fuel hurricanes. Warm ocean water is also going to change the position and strength of jet streams, and plays a role in El Nino events, which I've mentioned. Oceans are going to be a reservoir for carbon dioxide. Greater amounts of atmospheric carbon dioxide can dissolve in cold water. When cold, dense surface water in polar regions sinks, then we have carbon dioxide that moves to the bottom of the ocean. And oceans are also a source of atmospheric oxygen. 50% of the oxygen in the atmosphere comes from marine phytoplankton, which release oxygen into surface waters as a product of photosynthesis. Okay, so today we learned about the different technologies that are used to explore the ocean floor, how the oceans were formed, and how the water on our planet is distributed.